Hey, this is Craig. Welcome to the Valve Studio. Our journey to Tonehenge continues this week. I did take a week off and I went down on a road trip and then I'm back. My machine doesn't look like I've done anything on it, which is true. I haven't made any changes to this, but I have been working. No rest for the wicked here. I'll go ahead and show you what I've been coming up with. I have decided on the lift frame to use this stuff that looks like this. This is, well, in the old days it was called Unistrut, now it's called Power Strut. So Home Depot calls it Super Strut. This is an 1.5" by 1.5" piece. And I'm going to use this as the elevation, as the platform to put my WorkBee on. And I'm going to, this thing has a bunch of angles and all that kind of stuff that you can get at Home Depot. They also sell a half-size one. I'll show you that in a minute. That one is actually 13/16 by 1.5". And so 13/16 works out to be about 11 millimeters, which is a little bit bigger than our X frame here in the front and in the back. So I'm going to have two arms that go out the side, 3 cross members, and then I'm going to put it on a slide system. And I went out and downloaded a table of all the PVC tubing that you can get, or piping that you can get at Home Depot. And it turns out that I'm going to use that as my slide mechanism to kind of keep it as I'm raising it, because I decided on which way I'm going to go to raise it up. We talked about using linear actuators and the problems associated with that, and then I was going to use lead screws with gears and chains, and it's got all really complicated. Well, I saw I decided I need to use a scissor lift, like the car jacks that you have. You turn the crank and the 2 little things go up. It goes up like this. But I needed enough that I could raise the bed up with the spoiler board, get that up to the same level as my table, and then also be able to put it down and not, when I put the top back on the table, to be able to not collide with my Z-axis motor. And so I kind of determined that needs to be about at least 18 inches of lift. And lo and behold, I found the right scissor lift. Oh, this thing is a monster. They use these for, this is a 24-inch scissor lift. They use these for RV leveling. And I got this at Harbor Freight. It was about $34. And of course, I had a coupon that they sent me, so I got 25% off this item. So about $27. And this big nut over here is a 3/4 inch nut. I'm just going to power this up with a cordless drill. No big deal there. So that's how I'm going to actuate my lift platform. And then in order to keep it kind of, I don't want to completely support it on that. That's just the lift. So I need a way to keep it from tipping as it moves up. And I'm going to use this PVC pipe. This is 1-inch PVC. And the next size up is 1.25". And it turns out that 1.25" will fit over the 1 inch. And of all the sizes that they have at Home Depot, that's the only pairing that actually will be a valid slide. If you go down and look at all the IDs and ODs of all the PVC, this is the only 2 combinations, the 1 inch and the 1.25". So I plan on, on my Unistrut frame, I'm going to put a little piece of PVC here, the 1.25", and then I'm going to have a 1 inch, from the base of my workbench up to the surface, and that's going to keep this thing from, my frame from kind of getting off kilter, and it's going to slide really well because this is PVC, which is a low friction. Okay, so that's the lift frame. That's a 24-inch scissor lift, but when it's all the way down, it's 4 inches high, and when it's all the way up, it's 24 inches high. So the overall travel is about 20 inches. That's clearly enough space here. I estimate this to be about 18. We're good there. While I was at Harbor Freight, I wandered around a lot. You can't go in there without wandering around. I found this foot switch here. This is what do they call these? A latching foot switch. Click it for on, click it for off. I'm going to use this foot switch as the actuator for my vacuum system, because I'm going to be holding my pieces in a vertical position to do those finger joints, and so I'm going to hold both of those with two hands and get them kind of registered, and then I'll just click the foot switch to stomp it, and it'll suck it right into the to those Rockler vacuum clamps. All right, so I got that. While I was also there, I found one of these. This is a air compressor regulator with a gauge. I'm going to use for my mist system, I'm just going to use compressed air to blow the chips out of my work surface. So, my air compressor, I don't want to mess with the regulator every time I want to use it, so I'm going to mount this on the machine, and I'll be able to dial it down so that I get a decent volume of air coming in to blow the chips out. That was relatively inexpensive. Let me see here. That's that. The other thing is, I found this in the scrap bin. Actually, it was going to get recycled. This is an old. There's some electronics in here. This has got a bunch of relays in it, but it's a steel box. And look at this. It's got this beveled edge on the front. Oh my gosh, it's perfect. So here's my mock-up. I showed you my mock-up. I got my jog wheel, some switches. I got my feed hold switches here and a potentiometer. Well, wouldn't you know it, my mock-up and the beveled face of this enclosure is almost the exact same size. So I'm looking pretty good here. So now remember, I'm going to mount this thing somewhere to the machine, so it's in a fixed orientation. And if I bring this all the way forward, my Y gantry, and I put this, if I put this in, I have two choices here. I can orient it this way, or I can orient it this way. All right, so I'm going to opt to do it this way. One main reason is that going this way, I want to put an e-stop switch on here. So this surface down here is perfect for e-stop, but it'd probably be a lot easier to slam it if it's this way here. All right, so I'm going to mount my e-stop switch up here. Maybe my my feed hold, cycle start, reset. I'll maybe put those up here, and then have other features down here as well. And then I'm going to mount this. I haven't cut this cord off here yet. I'm going to mount this such that it kind of resides right here, so that it doesn't interact with I don't have a collision point here with X. However, ideally you'd like it to be out in front of the machine, so you don't have any kind of collision issues. But the area at which I have to lift this out of the table is kind of limited. So this thing actually kind of needs to rotate out of the way so that when I lower it back down, I don't hit the workbench at all, and I don't need to increase the size of this area here. All right, so I need a way to pivot this thing, and I need a way of pivoting it such that I can lock it in place, so that when I'm doing the jog wheel, turning the jog wheel doesn't have this thing kind of drift off. So this thing's got to be relatively tight after you do the rotation, but then you need a way to loosen it. So while I was over at Home Depot, I started looking at the fixturing, I don't know what they call it, the joints for PVC. And they have these things here. I don't know what this thing is called. This is some kind of joint that you butt two pieces of 1-inch PVC together, and then you can take it apart, and it's got this, this thing here, and it's got an O-ring in the end here. So it turns out this is a perfect friction joint. You can loosen up this big nut here, and then when you want to, so I'm going to mount this thing to the unistrut on the side. Just use the straight fixtures that you can get over there to mount pipe to unit strut. And then, so I'm going to have this thing down, you know, kind of over here like this. And then my enclosure box is going to sit up like this. I don't quite have this thing. I don't quite have this thing figured out yet, but so I'll be able to pivot it on this joint, and then when I get it in place, I'll just tighten this nut up and it'll stay in place. And then when I want to move it back down, I just loosen that nut up and twist it around and lower it back down. All right, so this is a really inexpensive solution for this. You know, this piece of pipe in here is probably about $2. This thing up here is about $6, you know, that kind of thing. And then, but I couldn't find a flange that would fit, a 1-inch flange that kind of fit inside of here that I can kind of screw to the bottom of my controller box. So I'm just going to 3D print that. All right. All right, that's the deal there. The next thing I worked on a little bit was I got these, this is a 30 millimeter Piezo speaker, a transducer basically. You know, you can get, there's things like this in smoke alarms. You know, they come in various sizes depending on how loud you want to get it. I got two sizes. I think I got maybe a 20 millimeter, that's diameter, and this is a 30 millimeter. And I wanted to see, you know, I just super glued a wood screw to this thing, you know, so what I wanted to do was kind of see, you know, if your, you know, your workpiece is going to come over and kind of touch this thing as you tap it, what kind of signal do you get out of this piezo element? I'll go ahead and show you that here. I just ran it, you know, now I got to tell you, you know, what the whole point of this is that I would like to have X, Y, and Z, X, Y, and Z probe, not just Z probe, so I can establish my 0 point on my workpiece, you know, that's independent of the machine coordinates. So by using this, I did do some tests of the different axes. So ultimately, I'm going to make a fixture that holds this upside down, not with this wood screw, but something a little bit more sophisticated, that holds this upside down and mounts in the bottom of the spindle because you want everything registered to the spindle itself. So this side up here needs to be a 1/4 inch shaft, and then I need to get the registration right on the money for the thing. And Rob, my friend that runs a machine shop here, is going to help me with that. But basically, for my test on what kind of signal I'm going to get out of this, you know, I didn't know if it was going to be millivolts. I don't know what it was going to be, microvolts. Now, the PSOC that I'm using, remember I'm using the PSOC 5 for my controller, not an Arduino board. PSOC has an analog subsystem, so I can do analog filters, analog op amps, analog comparators. I can, and you know, it has A to D converters as well as DACs. And so, but I don't need to use an A to D converter. I need to use an op amp and change the gain, and then set a comparator up such that when you touch this thing, you trigger the probe input on Grbl. I'll go ahead and show you a picture of my little test thing. I got this wired directly right into a scope. My scope probe is set on 10x, so it's 10 meg ohm input impedance. And basically, I tried to go in and tap this thing really as fine as I think that I would want to tap my workpiece. And you can see here that the voltage level is really high. I'm really surprised at how high it is. What is it, like, I think it's about 2 volts, which is like awesome. What that really means is that I can run that voltage, that analog voltage, through all the cabling and bring it back into the controller box and not have to worry about noise getting, you know, injected into it because the signal is so strong. All right. What else is next? All right, 2 more things. I'll show you this here. I'll just do a screenshot here, but there's a guy out there that works on these Grbl ports. His name is bdring, and he's been doing a lot of stuff in the maker world for a really long time. if you look him up, you can find out that he's kind of influential in this, kind of behind the scenes. And so, you know, when I found his Piezo Grbl project on GitHub, it was kind of an old project, and I thought it was kind of alienated because it was a year old and there was only one revision, which was the initial commit. So I contacted him and I said, you know, he had other posting on his build log about other his Piezo implementation be able to run 4-axis machine. And so I contacted him about getting that code instead of just the year-old code, because he's probably evolved it over time, but he never really checked it back in. Told him what I was doing, what my plans are, and he worked quite a long time to kind of clean things up enough to do another submit. And so over at his GitHub page, you can download a thing called a USB Grbl, which is a Piezo 5 implementation that uses the Piezo's internal USB controller, such that when you connect it up to your eval board here, your 059 eval kit, you're not tied to the baud rate of the UART. You're now running at USB FS speed, which is probably, I don't know, easily a megabit per second. So your query times back and forth are not going to plague the microprocessor, because the internal USB controller, you can just take all those commands and throw them all in, and the microprocessor can go off and do more Grbl kind of stuff. So he submitted that, and I started looking through there to find out what he did, and he made quite a bit of difference between what he did a year ago and what he actually committed this time. And what he committed now is going to do 6-axis, but it's not all enabled in hardware. So if you want to do 6-axis Grbl, you can do it, but you got to become a little bit more you got to generate a little more expertise in using the Cypress creator, and be able to enable the step and the direction bits in the control registers. But the software is all implemented. It's just defined to do 4-axis, which is going to be, you know, not what we need here. I can define it to just be 3-axis, and then we'll be able to do I'll set up my WorkBee. All right, so I kind of felt indebted to him. So, you know, I said, let me work on something for you. So he gave me 2 little projects, and I got one finished. One of them is getting SD cards, getting the Piezo 5, generating a project that's simple enough to read files off the SD card. And I took the Cypress example and got it all working in the Creator tool, enough to read my full-size SD card. And so if you look back at my wiring diagram, the controller does, ultimately, it's like, was it going to be a future project to be able to read off your Grbl files from the SD card, but I have that whole piece kind of being able to read those files. Now I got that figured out. Now here's an interesting thing if you're really you know, into all this. He released today his Grbl port for ESP32. Now ESP32 is a microprocessor that has got Wi-Fi and Bluetooth in it. It's the follow-on successor to the ESP8266. It runs at 240 megahertz, so it's a screaming fast microprocessor. He released that today. He hasn't released a source code for it, but there is a video on his build log about getting that to function. And with that, then you can actually use things like our Android senders or iPhone G-code senders, and not be tied to the USB port, and then just have your machine kind of not make a connection back to the mothership, and have a USB cable dangling about. That's an exciting thing. I'll go ahead and show you where my project is for my SD card, and then I'll go ahead and show you, you know, I'm just going to put a link in there for the video that he talks about his Grbl ESP32 implementation. I think that's it for today. Thanks for watching. This is the Valve Studio.